T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff.
You're looking at the historic B-Test complex at NASA's Stennis Space Center, where we're about to do a second Green Run hot fire test, firing up the core stage of our new Space Launch System rocket. Good afternoon. I'm Lee D'Angelo. This stage we're testing today will be part of the rocket, which will soon launch from NASA's Kennedy Space Center on the Artemis 1 mission. That launch will send an uncrewed Orion spacecraft beyond the moon and back to Earth. It's the first flight of the Artemis program, which will return American astronauts to the moon and pave the way for exploration of Mars. The Space Launch System will be the most powerful rocket in the world and is the only rocket that can send the Orion spacecraft, astronauts, and supplies safely beyond the moon in one launch. Now, we first tested this core stage on January 16th. That marked a major milestone, firing all 4 RS-25 engines together for the first time for about a minute. However, it ended earlier than planned, so NASA and Boeing decided to do a second test. Teams have been working hard to get to this point, and the test countdown actually started a couple of days ago. Here to update us on where things stand is NASA Public Affairs Officer Catherine Hamilton and Headquarters Green Run Manager Bill Robel in one of our test control centers here. Catherine?
Thanks, Lee. We're inside a secondary test complex outside of the control room, and we're listening in to provide you updates as the team progresses through their steps for this operation. We believe we're within about 45 minutes of the hot fire. The team actually started 2 days ago powering up the avionics on March 16th, and they checked out all the systems that they had tested on previous tests. Earlier this morning, they conducted a go-no-go poll to proceed into the test, and I have Bill Robel here with me to tell us a little bit more. Bill, can you tell us about how the operations have progressed today?
Yeah, sure will. So at this point, we've been in kind of replenish mode for both the liquid oxygen and liquid hydrogen. We've got, at this point, 540,000 gallons of liquid hydrogen on board and another 200,000 gallons of liquid oxygen on board. And they're in the conditioning process right now, where we're trying to get that temperature down as low as we can, get it within the start box. And we're also doing the same thing on the engine side of things. And what's important about all of this is that, this timeline that we're going through here will help inform the operations that'll take place down at Kennedy Space Center, where not only do they have these things to worry about, but then they've also got to do the things where they're getting people on board and taking care of all the other extraneous things that they have to do down there. So for us here, right, we've also been monitoring things like the battery charging. They're basically up to speed at this point. And then we've got the redundant inertial navigation unit wet checkout, which is basically mounted up in the LOX dome area. And so they're looking to see how it behaves relative to the low temperatures that we're seeing now in that compartment. And so at this point too, the teams are basically looking at all their data, making sure that their systems are where they're supposed to be and ready to go for proceeding into the terminal account.
Thanks, Bill. And can you tell us a bit how the timeline is different for today's test than for a launch, and how is determining the time of the hot fire different from setting the time for a launch?
Yeah, so for us, it's actually we're in a pretty good spot. We're trying to at this point maximize the amount of commodities that we've got here in the test facility. So we're playing a little bit of a game where we've got crews that have been on for a number of hours, and at 12 hours roughly, they'll time out. We want to make sure that we don't have to end the operation any earlier than that, so we're really trying to maximize that. So they're in the process of working that with the nitrogen and helium, liquid oxygen, and liquid hydrogen. The other part of it is, right, the beauty of us is we're in a test. We're not going anywhere today, and so we don't have a destination. Our destination is right here. And so the difference right at Kennedy is they've got, the orbital mechanics, their destination as to where they're going to go. And so they have to work basically all those details in to their exact launch window. Our launch window is basically when we start the test, and that doesn't matter too much today. But they do have they've got a real time hack that they have to hit. So they'll have built-in holds into their process and procedures down there. And that'll inform them kind of how they move through the next steps. We just are fortunate we don't have to worry about that today.
Great, thanks. So that means that we don't have a specific hot fire target time right now at this moment, but we'll keep listening in and we'll provide updates. We do know that the test remains to be projected within the test window, and we believe we're within about 45 minutes. And so we'll continue to listen in here, and I'll turn it back to Lee.
Thanks, Catherine and Bill. And we will come back to you in just a few minutes, like you said, to take us all the way to the test, or sooner if you have any updates for us. We will be listening in, and I'll head right back to you if you do. Now, if you are just joining us, welcome. We're live at NASA's Stennis Space Center in Mississippi, and we're following the second Green Run hot fire test of the Space Launch System rocket's core stage. The core stage is the center core of the rocket that includes 2 propellant tanks and 4 RS-25 engines, miles of cables, all of the avionics, electronics, computers, the brains of the rocket, and all of the plumbing that work together to launch the rocket during the first 8 minutes of the mission. The green in Green Run refers to new, untested rocket hardware. So this is a comprehensive series of tests of all the core stage hardware for the SLS rocket to demonstrate it's ready for launch, culminating with today's hot fire. The core stage will power every SLS mission. So this test is important not just for Artemis 1, but for all future SLS launches as well. Those RS-25 engines are expected to fire up shortly here at Stennis Space Center. Before that happens, let's get a closer look at the Space Launch System rocket. Super heavy lift rocket and provides the foundation for human exploration and scientific missions to the moon, Mars, and beyond. Powered by 2 solid rocket boosters and 4 RS-25 engines, this rocket provides unprecedented power and capability. Designed to reach 23 times the speed of sound and an altitude of more than 100 miles in just over 8 minutes, offering more energy, volume capacity, and payload mass than any rocket built today. Under the launch abort system, Orion, and the upper stage, and between 2 solid rocket boosters is the heart of every SLS configuration, the core stage, towering 212 feet with a diameter of 27.6 feet, and storing 537,000 gallons of liquid hydrogen and 196,000 gallons of liquid oxygen. This is the world's largest core stage ever built. The core stage for Artemis 1 fires up for the first time at NASA's historic B-2 test stand. The core stage was designed by NASA's SLS program at our Marshall Space Flight Center in Huntsville, Alabama. Then built by lead contractor Boeing, using state-of-the-art manufacturing just down the road at NASA's Michoud Assembly Facility in my hometown, New Orleans. It includes engines manufactured by Aerojet Rocketdyne, with contributions from more than 1,100 large and small businesses in 44 states. It was shipped up here to Stennis on the Pegasus barge in January of last year, and then installed on the B-2 test stand where you see it here today. Engineers then began activating the stage's components one by one and taking it through the series of tests that make up the Green Run over the past year. Each test built upon the previous one and added a little more complexity. So today's hot fire builds on all of that work for a full test of the entire integrated system that will simulate all parts of the core stage working together during launch. Today's test will take us from extreme cold to extreme hot as the team loads cryogenic or super cold propellants into the fuel tanks and then fires up the engines to drain the propellant from the tanks to simulate launch. Now, the hottest part of the test today will be those 4 RS-25 engines at the bottom of the core stage. These RS-25s we are testing today are repurposed from the shuttle program. These 4 engines flew on some pretty iconic shuttle missions, including one of the Hubble Space Telescope servicing missions, the historic return to space of Mercury astronaut and Senator John Glenn, 6 flights to the space station, and the final shuttle space mission in 2011. So you can trace a direct line from that final shuttle flight to the first flight of SLS. We've worked with our partners at Aerojet Rocketdyne to upgrade the 16 shuttle main engines, which will power the first 4 Artemis flights. And now we're building 24 new engines using 3D printing and other manufacturing innovations to reduce cost, complexity, and manufacturing time. Of course, all of this work is building towards that Artemis 1 launch from Kennedy Space Center later this year. Here's a closer look at that mission and how it paves the way for future exploration beyond.
3, 2, 1, 0. Mission liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there, within the next couple of decades.
Just amazing. And now we are going to hand things over to Catherine and Bill again in the control center. Catherine?
Thanks, Lee. We are in the secondary test control and outside the control room here listening in so that we can provide you updates. Bill, can you give us an update on how things are progressing?
Yeah, so they're in the process now of going through the final checks. Everything's really nicely going really great today. So everything's right on schedule, nominal. They're trying to do this thing what they call right now is jump the clock, which is trying to work it a little bit ahead. So they're in the process of resetting the clock and making sure that when they get to that 10-minute point that it doesn't continue to count down, because that's where they have to go with that pole well ahead of that. So they're working on setting that stuff up right now.
All right, so we'll continue to stand by and listen and provide updates. And as Lee mentioned earlier, the team previously conducted a hot fire test in January. The engines did shut down earlier than planned during that test, but the January 16th test successfully completed several operations for the first time. They were able to transition to the automated launch sequence operated by the core stage flight computer and the green run test software. They completed the terminal countdown sequence that is like the launch countdown. They also pressurized the tanks and delivered the propellant to the engines and demonstrated the performance of the core stage's main propulsion system, firing the engines at 109% power, and they operated the thrust vector control system that steers the engines. So it's a smooth countdown so far today, and we'll keep standing by. We'll take a pause for a moment, and we'll check back in just a few minutes.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition and liftoff.
CAPU start, and basically those will be coming up on helium. They'll go into a what we call the wiggle test, which is where they'll gimbal the engines, and then so that's basically coming up here in just a couple of minutes. On the plus side of that, once we get into the engine starts,
T-minus 4 minutes, CAPU starting LO2 securing.
Okay, so LO2 is being secured now, so that they're really moving forward in the plus count here. Still roughly at T-minus. .42 seconds. And so with that, we should be seeing the TVC gimbal profile here in about half a minute or so. Basically at this point they've got the water system all turned on. You might be able to see that in some of the views, and that'll basically take care of not only the heat coming off of the engines, but also dampen the tremendous amount of noise that'll be coming off. As mentioned earlier, the hydrogen burn-off igniters will come on at about 12 seconds.
T-minus 3 minutes starting PSN 4.
The inertial navigation mode will be complete at about T-minus 10 seconds. And then basically the enable command for ALS at 9.2 seconds. And then we go into engine start roughly at 6 seconds. Those take about 5 seconds to come up to full operating pressures. And basically at that point, the stage controller will be go for launch, or go for test in this case, at 2 seconds. And basically we go forward into our profile for the day.
All right, we're coming up on 2
Here's
minutes.
the gimbal test taking place now.
T-minus 2 minutes.
So the call was they just announced at T-minus 2 minutes, which is basically they have finished the gimbal test with the actuators and they're bringing them back into the null position. And then basically at this point they basically are getting ready for powering up the engines. Again, core stage transitions to internal power at roughly 1 minute and 30 seconds out.
T-minus 130, switch to internal power.
And then if Reno gyro compass alignment converges at roughly 1 minute. And then we'll have to go for ALS. And we'll clear that polar shortly at T-minus 33 seconds.
T-minus 1 minute, following personnel report go, no go for ALS, AEA, PEA,
Go.
AGA,
Go.
RDA,
Go.
NEA,
Go.
NTC. Vehicle and B2 systems are go for ALS.
Great. And you, at this point you see basically the water system has come on full bore.
All right, T-minus 30, we're in ALS.
And you just got the official start of ALS. Next up is the hydrogen burn-off igniters come on at 12 seconds before T0.
Red line like this. H-boys on.
Go for engine start.
H-boys are on and engine starts has been okayed. Engine starting up now.
And all personnel, we've got engine start and we're for the plus count. All personnel, please continue to monitor your system and grass is in control. Plus 60 seconds starting TBC profile number 1. Again, first now we've got a fire to everyone go into TS. So TS. Thank you. Okay, copy. Do you want me to hold down ATS? Okay, copy that. Cancel it out. Profile, remember? Jim 30 seconds, starting the FRT profile.
3.5 minutes into the plus count.
Camera's number still good. That's the resolution. And it's a beautiful time. It was 4 minutes 30 seconds. I shoot in the FRT profile. Top item 16. It was 5 minutes.
We're just over 5.5 minutes in the plus count.
It's about 6 minutes. Over there from Michael 16. Yeah, I'm not seeing any TCC violations, so I copy, we're good. Thanks, sir.
We're coming up on 7 minutes of the plus count.
G plus 7 minutes. And G plus 7 minutes, 30 seconds, starting TBC profile numbers. G plus 8 minutes. And then the TBC profile number 6.
All right, so we're just over 8 minutes into the plus count.
Personnel are coming up hopefully on a loss depletion here, and we have a cutoff. All right. REA, can you verify REA on channel 16? REA on channel 16, safe engine shutdown, please.
Safe engine shutdown.
And you're in post-shutdown standby, correct?
Correct.
Okay, all personnel, that takes us to page 656. All personnel go to page 656 to start the post-hot fire shutdown securing operations.
All right.
Okay, all personnel on page
Bill, as you said
656,
earlier, as we talked about earlier, the team was hoping to get at least 4 minutes of data. And we All right, they are proceeding with their shutdown procedures now. As we said earlier, the team was hoping to get at least 4 minutes of data, and they did get more than 8 minutes, excuse me. So they should have gotten what they need. The team will obviously need to look at that data, but based on what we've seen, Bill, tell us more about what it looked like to you.
Yeah, so they clearly got the full duration that they were after, which is really great news. And I think you heard the applause. They had, the commanded shutdown, which is exactly what they were looking for. They had no TCC violations, test commit criteria violations that would have prompted an early shutdown. So that was really good news. Clearly there's a lot of data that's going to have to be analyzed. The engineers got to see what worked and what didn't, or what needs to be tweaked and what doesn't. But that said, I think the applause says a lot about how the team feels, that they got through the test, and it looks pretty good right now.
T-minus 10, 9,
Yeah, so
8, 7, 6, 5, 4, 3,